Hello, I'm audible, right?
Oh,
Confirming.
yes, sir, you are audible.
Okay, okay, thank you. Okay, so you're able to see my screen?
Sir, no, it's not visible as of now.
No?
Yes, sir.
Okay, cool. So, good afternoon, everyone. So, we are continuing from last session, which was on Monday, and we're basically building this game, which we have called Color Run. We are setting up this right now. So just if there's someone who had not joined in the last session, the objective of the game is basically you're controlling a ball and you can move from side to side, left, right, and you have to pass through some blocks and you're only allowed to pass through blocks which are of the same color as the ball that you're controlling. If you pass through any other ball, game is over. Any other obstacle, game is over. If you pass through the same color as yourself, randomly your color will change again. So this is the base setup, and there's obviously a lot that can be done. Until now, in the last session, we have basically set up the base of the game. Let me move there. Hi, so I think I got disconnected in between. Can
Yes,
someone
sir.
tell me where I was? And are you able to see my screen now?
Yes, sir. It's visible now.
Okay, okay. And like, when did it stop?
Like, sir, the moment you switch to the screen, then only it was stopped.
Okay, okay, cool. So we didn't miss anything yet. Fine. Sorry about that, guys. Let me just check my internet once. That's fine. Okay. So in case I get disconnected again, just as someone please call me or something so that I'll know
Yes, sir.
immediately.
Sure.
Uh, yeah, there's some problem with my internet today. So sorry about that. Anyway, so continuing. So basically, what we had set up in the last session was this base where our player is, and we have set up the code for the player to move left and right, the camera to follow that player, and basically the scene that you're seeing, the which was set up through something called a skybox. And we also looked at what a skybox is, how it works, how to set up a skybox. Just to repeat it very quickly, we go to Windows, rendering, lighting, environment. Here we have skybox. This this is where we set up the skybox material, and this is an asset that we downloaded from the uh, Unity asset store. And we also downloaded another asset from the Unity asset store, which is the joystick pack, which we'll use in the next few sessions, or like maybe today itself. We'll basically set it up to uh, create touchscreen interaction for mobile phones, because we'll also try to build the this game for Android or mobile-based solutions. So moving on, today what we'd like to do, like what's the next step that we want to perform is basically to set up more things, and one by one we'll set up those things. So the immediate next thing that we want is basically when we see the game, we realize that every time that we start the game, there's obstacles coming towards you which are of different color, and the player starts with a random color. So both these things can be done using a single script, where we basically create a script that out of, let's say, four colors, picks one color at random while we are while either the obstacle is being spawned or the user has just started out. So we'll create that script. Create a new script, and we'll name it random color selector. And along with this, we'll also create another script. So we want to use this script, random color selector, but we also want to create another script which will call as game manager. So game manager is a special script in Unity. So whenever you create a script called game manager, you'll see that the icon changes. It's not as a C# script, but when you open it, it's just the same as any other script. So it's just special in name, that Unity recognizes that this is a script which is different from others, because this is where you want to create a management logic for your game. So this is where we'll start creating some of the stuff for like spawning the obstacles, or defining what colors we want and stuff like that, right? So to start with, we want to create colors only. First, we like right now what we are doing, the function that we are implementing is basically trying to implement a random selection of colors in both the obstacle as well as players. Go back a bit. And for that, we will, in the game manager, we will create a public static color array. So color is a class which basically is a representation of RGBA colors. So it holds four values: red, green, blue, and alpha value. So this is how generally colors are represented in Unity everywhere. There are four values. So like there are other color space, like color representation formats that are available. There's HSV format and all those things. So RGBA is one of the most common things that are available. If you know about this, generally the values go from 0 to 255 in each of these categories. So red, green, blue are primary colors. Mixture of these categories basically create other colors. So let's see if we can see it somewhere. See in the materials, if we choose this and this, so you see there are four things here: RGBA, and then there's a hexadecimal color value attached to it. So this is another way of representing a color value. So RGBA is basically a combination of red, blue, green, and blue. And then alpha is basically the value of how much basically transparency. So this also goes from 0 to 255. Transparency or opacity. One side it's transparency, the other side is opacity. So how much transparent or opaque do you want the object to be, right? So this is how RGBA is represented. Another way, like I said, is basically to represent it using hexadecimal. But the class that we are creating right now, this color class, is a representation of the color in the RGBA format. And this we have kept as static because we want to access the class that we are like the array that, so we are creating an array called colors, and we'll hold the value here, four values for now. And what we want is basically to access this array in different uh, in a different script, which would be a random color selection script, right? So next, what we want to do is in our awake function. We already know what awake function does. So in our awake function, we can just define these colors manually for now. Obviously, there are many different ways of doing this, but let's just go ahead with doing it like this. So colors1 equals to, and let's take blue, red, green, and yellow colors. So color dot blue, red, green, and yellow. So obviously this is one of the easiest ways to fill up the array in the way that we did. There are other ways which we could have done this by, like let's say by like keeping it in the as a public variable where we could have set it in the inspector window as well, like we said other things, like when we attach some reference to a script. So something like that can also have been done. But for now, this is the easiest way that we can do it. So this is what we create for now. And in our random color selector, what we want to do is basically whenever there's in this object is created, all we want is that this object's get component. So by now, I think you know what get component does. So get component inside of a game object basically checks if whatever you give here, whatever type you give here. So here I will write as renderer. So this will check if there's a renderer component attached to the game object that the script is on. And then I'll check inside the renderer, what I want to do is check for material. And inside of material, I want to check for color, right? And in this, now what, so how does this work? So like where is get component renderer coming from? So if I check my game, I'll go to player, and basically this will, I'll have that script attached here. That script will check if there's a renderer attached here. So we do have a renderer here. So this is the renderer that it will get. And in that renderer, it will get the materials. Materials is this player mat material is attached to it. And we are able to access the color of this player mat material inside this, right? So we are doing this. And what do we want to change it to? So what we want to do is we have just created game manager dot colors, and we want to create a chain, like get a random value of this color. Sorry, it's an array. So what we want to do is again random dot range. We have already studied this, and this is something that we can do, right? So again, to recap, what we did was two things. First thing was basically define four different colors in a game manager script. We kept this array. Something happened. Oh, sorry. So we kept this colors array as a static object of the color class. This color class is a representation of colors in the RGBA format. Then next, we created four colors inside this array because we have created this array as a four dimensional array. I think what I did wrong here is I started from one. Arrays in Unity start from 0. Sorry about that. Put that, I got it here. And after this, what we're doing is accessing these colors in the random selector, where what we are doing is wherever this random selector script is attached, this script will check that game object's renderer, material, and then color, and assign the color a random value from those four colors. How is that happening? So we can, because it's a static array, we can directly access the uh, array by calling it from game manager dot, like calling it by using the class name itself. We don't have to create an object of the class. So we know this concept of oops, right? So this is like you must have studied it in C++, or if you've studied C# before, this is a concept, right? That static objects can be called directly. You don't have to create objects of the class to access them. So that is why we did that, so that we'll be able to easily access it. And it's also public. That's why we're able to access it here. So then we access that color, and then in that color, what we're doing is doing this random dot range, and in the range we are from 0 to the length of the colors, one value is generated and that color is chosen. So let's save the script over here. Sorry. Here we create a new object, zero it out. So this game object will be our game manager object, and let's attach the game manager script to this. Make it at the top. Anyway, we can leave it there. And then in the player, we want to attach the random color selector. Let's see if this is working. So like you can see right now, the player is red. And let's see when we play what happens. So it's working. Like this is what we wanted. Every time we play, it generates a random color for the player. It's mostly green, but it is random. Or I think we can change the seed or make it more random. This one is yellow, or maybe we are getting green every time. So maybe, yeah, if once we do it enough times, we are able to see the randomness. So that's how random works, because we have a very small sample space, only of four. You'll see repetition also a lot of time. So next, obviously, there's different methods that you can create randomness. That's a whole different math of how random numbers are generated and everything. If you're interested, it's very interesting theories that are there. And there are many different ways of selecting random numbers from different probability distribution. So that's a good concept. If anyone's interested, reach out and I'll share some good literature on it, some good resources on it. So yeah, so this is our part about setting up the color changer. Now what we want to do next is basically set up the obstacles. I think let's set up the obstacles and then we'll see how to create the movement of obstacles. So basically our obstacle is going to be just a 3D object, which is a cube. And let's call it obstacle. And let's zero it out and maybe change the scale a bit to, and give this a bit of height, maybe a bit more so that it's above ground. Yeah, so this seems okay. And let's create another material. Obstacle mat, and basically randomly assigning it some color. So our obstacle, this is going to be our obstacle in general, right? And what we want to do is basically use this obstacle as a trigger that so that we can detect collisions between the obstacle and the player. So let's change this now. And other than that, right now we don't need to change anything. We also want to attach the script that we have just created, random color selector, to this obstacle. That will work. And now let's create. So we'll eventually change this obstacle to a prefab, and then that prefab will generate spawn random obstacles and then move the obstacles towards us. Right. So next we'll create a obstacle movement script, and let's go to the scripts and create script, and let's call it obstacle movement only. So just for making it move, all we need to do is in our fixed update, in our fixed update, we'll do this dot transform dot translate, and we have already done this thing before. We know all this, what translate does, and what do we have to give to translate function. We have to define the movement, so we'll do vector, sorry, vector 3 back into time dot delta time into some value which will be force, like this will be the speed or force or whatever. So you can call it speed, and let's define the value speed. So public float speed to start with 20. So this is what will be attached to our layer, no, sorry, obstacle. And yeah, let's go to the obstacle, attach the script. So right now all we have done is basically created uh, the movement script for the obstacle. next what we want to do is basically create a spawner for these obstacles. So for that, what we'll do is just a second. In our game manager, this is where we'll manage the spawning as well. So for that, what we will have is basically, if you remember, there are some things that we want when we want to spawn anything. So one is basically the game object that we want to spawn. So this will be the obstacle prefab. This also we have done before, the same thing as before, similar. And then the transform of the parent that we want it to be on. Let's call it obstacles. And we have not created this yet, we'll create it. And then let's write a function called as private void spawn. And in this, what we want to do is basically create some obstacles every few minutes, every few seconds. We want to create some obstacles, right? So let's do this for now. Instantiate obstacle prefab comma, and we want to define the uh, direction of where we want it to start from. So basically, I will check. So we want it to start from somewhere here and then move towards here. So this is basically try to see it from the top. So there's a z direction that we have to define, and then a x value that we have to define between these. So like some random value that we have to define here. And so like this would be somewhere 6, I think, and this would be -6. So we want the obstacle to be like, if you can see this properly. So like if we click on this, we get a orientation, like different view where we can basically see everything properly from that direction. So like if we see, this is -6 and this is 6. So this is the x direction. This is where we want that obstacle to spawn between -6 and 6. And the height that we wanted to spawn, that is the y direction, is going to be 1.5. This can be 0 for now. And the z direction that we wanted to spawn is, let's see, basically somewhere around here. So that's at about 110. So these are the values that we have to give to our new vector 3. So this is what we define here in vector 3. What we want is basically a random value between for the x direction. We saw that we want a random value between -6 and 6. And to do that, what we can do is basically, if we see the game, let me take you here. And basically, if you see it properly, you see that two of them are being spawned together. like two of them are spawned in a row, right? So for that, we'll have to write some kind of a loop and start it like that. So like every obstacle that is coming in a blocks of two. So how do we do that? So for that, we'll create a loop, and in that loop, we'll define these value as well. So we'll start with an int I. This will be the value that stores the value for the x-axis as well. And then for I equals to -6, because this is the value that we want, and I is less than 6, and then I plus equals to 6. So this basically is a different way of running a loop and basically getting this value. And in this, we'll write, now we can write a function where like obviously we want random dot range, and that can be between I, which is going to be -6, or eventually becomes 0. So like we want to change the value of the second obstacle, right? So like imagine this loop runs for the first time, it comes. The first time the value will be -6, right? And the range that we want to define is I to I to I plus 6. So the first time it comes, the range that is defined is I to I plus 6 and -6. So the range is -6 to 0. So this is where one obstacle will be centered on the left side wherever it is. Then we are doing I plus 6. So the value becomes 0. And then again, we want to check from 0 to 6, the second range that is defined. So once the loop runs, the obstacle for the left side is created. The second time the loop runs, the obstacle for the right half of the section is created. And then there's another function that we can wrap this in, is basically a math function. I think we have to include some library for that. Let me check. Not really, should work as is. So mathf dot floor is a function which we wrap this whole random range thing in. So what does mathf.floor do is basically returns the largest integer smaller than or equal to f. So it will return us the largest integer value. So till now, this random dot range is going to return a float value, and this will basically floor that float value, and this floor method dot floor is going to change that float value to a integer value, and that integer value will be the floor value. So we know the concept of floor and ceiling when we write parentheses like brackets, square brackets. So we can square or floor values, right? So floor or ceiling values can be defined. So this is what we are doing when we are flooring the values. So in the floor, it will return the largest integer, which is smaller than or equal to the float that is inside this. So whatever this returns, this will floor that value. And then for pi, we will have 1.5. And for x, we will have 110. And here we need an f, and that's all. So this is our position. Did I do something wrong? No, it's fine. So this was the position. Next, what do we want? We want this thing, quaternion dot identity, if you remember from the last time. And then we have to define the parent. So that's it. That's all there is. I hope this was clear. This whole function is a bit complicated, but this is where like you see the beauty of uh, code and try to understand how different functions or how small things that you learn can be used to manipulate visual things inside the game. So let's see if this works. And first, what we want is basically to create a prefab for this obstacle. Let me do that. Let's basically create a folder called prefabs. This prefab folder, we'll just drop this and we can disable this in our scene. And in our game manager, we will drop prefabs and we'll create a new object, obstacles. And we can zero it out. And this will also be attached to our. And let's see if this works. We can put it side by side to see how this looks. So yeah, so obviously it won't work right now because we have not yet called that function anywhere. So we created this void spawn function, but we have not really called it anywhere. So for doing that, we will create a start function. And in the start function, we will introduce a new function, which is known as invoke function. So there are two methods that are there, invoke and invoke repeating. So invoke method is a function that invokes the method name. Like I hope you can see this, or let me just open the documentation for this. That'll be more easy to see. Invoke community and invoke repeating. Sorry, I think I got disconnected. Am I audible now? Hello.
Yes, sir. You're not audible.
Oh, thank you. And you're able to see the screen also, right?
Yes, sir.
Yeah. Thank you so much. So yeah, so we're talking about two functions. One was invoke and one was invoke repeating. So the invoke function basically invokes the method, whatever method name we provide, and there's a delay that we can give it. This is the delay of time that it takes. So like let's say we write this function in our start method or update method wherever we want to call a function. So this is the function that we want to call, but we want to delay the calling of the function. Like let's say some event happens. Uh, like let's say there's a bomb that I throw and I want to blast it after 5 seconds. So this is where I can use invoke function that I throw it. And when I throw it, I'll trigger the invoke function and the invoke function will have the string method name that I passed to it would be, let's say, blast, and then the time of 5 seconds. After 5 seconds, it will call the blast function. What does invoke repeating do? So invoke repeating takes one more value, which is called as repeat rate. So this is a function where you want to continuously repeat the invoking of this method. So the uh, invoking, like the first two things still remain the same. This time is still the time that it starts for the very first time. And then there's the repeat rate. So how much time after it keeps repeating. So this is what invoke repeating does. And invoke repeating is useful in places like where we want to use like uh, what we are doing is basically once we start pushing the obstacles, like moving the obstacles, after every, let's say, 2 seconds or 3 seconds, we can keep on changing the uh, rate at which, like, keep on spawning new obstacles. So let's use this. Obviously, there are again, so there are whatever we are doing, there are like 5 different ways, 10 different ways of doing the same thing. But right now we are just exploring different new functions, new methods, new type of writing code, so that you explore these things a bit. And then obviously based on what kind of functionality that we want. So let's say right now what I'm creating is basically a static method where obstacles are being spawned at repeated intervals of time, but those repeated intervals of times are fixed. Like it will be spawned after, let's say, every 3 seconds only. But maybe I want to change the frequency of the obstacles with time. So like I want it to feel like that the speed is increasing. So for that, what I'll do is basically I would like to change this time period that is there in between. So there I might not be able to use the invoke repeating function. I might have to use some other function or a completely different method of setting up the whole game that we are setting up right now. Right. So that is how a lot of things can be different, and that is how these all things can be different. So yeah, so let's see how this works. So we want to use invoke repeating, and the name of our function is and I got disconnected. Did I get disconnected again, or am I still here?
So you are here only.
Thought I heard something. Okay, sorry.
Your voice is breaking in between.
Just in case something needs loading or something. So 1 second of delay to start this function. And then let's say every 3 seconds, we again want to keep repeating this. So this is a function that we for this. Let's see now how this works. So as you can see, obstacles are moving towards us. They're coming at quite a fast speed. And this is basically what we wanted to set up. Right. We can obviously change things to more better things and stuff. So like right now, what are the flaws that you see in the system? So one thing is that like it's not a flaw, but one thing is that we have not still set up the scoring and stuff like that, which we'll do. Scoring or even uh, the whole point system, like basically changing of color when we hit a obstacle of the same color. So we have to set that mechanism up. But what you also see is basically that the obstacles that are being generated, they stay there forever. So like if I keep this running after a long period of time, like these are the obstacles that are still there in the scene behind our wall. So we need to do something about this as well. So these are the two things that we are going to address next. One is the mechanism that we want to implement, and the other part is basically to deal with this extra obstacles which have crossed our play field of view, which have crossed us and they are behind. And how do we deal with that? So these are the next two things that we'll address. Let's see. So to do that, we will go to the obstacle movement script and obstacle movement script here. And why do we go to this script? Because what we want is basically in our obstacle prefab, we want access to the collider this thing, which is a trigger. So we want the access to the trigger, and when this trigger is hit, like when this obstacle hits something, it can either hit the player or it can hit the uh, this boundary wall. Sorry, this wall that is behind us, which we already named as obstacle wall. So these are the two things that we want to check. Whenever the obstacle
So you're not audible.
so
Sir is rejoining. Everyone, please be here only.
Hi, so sorry about that. Let's just quickly get back to it. Are you able to see my screen?
Yes, sir.
Yeah, so just a minute, I have to close everything. We are doing this. Yeah, so this is what we wanted to do next is basically wanted to check for the trigger. So for that, we have seen this before, this function before, and hope you guys remember. We want to check on trigger enter, and this is where we make use of a new programming concept, which you already know, switch cases. So what do we want to do here is basically switch. And what do we want to switch is basically this collider other dot tag. And in this, now we want to write some cases. And we can have a case of player, which we will set. And just for now, write the break, just so we see how many, how to actually write this. And we can have another case. Oh, sorry, I quickly spelled this break. And we can have another case, and let's call that obstacle wall. So this is our other case. And then again, break. So this is what we want to do. And what we want to do when we basically uh, reach these places. So obstacle wall is pretty clear, right? So what we want when the obstacle reaches the obstacle wall is just destroy. And this destroy function also you already know. We want to destroy this game object. But player is a bit tricky. So in the player, we want to do two things. We would like to check that if uh, the obstacle that is hitting the player, so is this dot game object, this object's color. And how do we get color? We get component renderer, sorry, renderer dot material dot color, and which, what do we compare it with? We have, like, we'll need to compare it with the I think best to just stop having a lot of connectivity issues. But we'll pick up here in the next session. And